Hey everybody, this is Larry. This is day 23 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this video and all these things. As you can tell, I'm outside again. It is very nice today. And that also means that I have a new video out on my other channel. It is to talk about one of the questions I get a lot, which is, in which order should I learn all these algorithmic topics, right? If you're interested about that, check out that video. Thank you. Hey everybody. Hope you like that intro of me walking around New York City as usual on Mondays anyway, or whatever. But I'm very excited and happy right now because I just watched the end of the Knicks game. Spoiler alert if you are following the NBA and the Knicks fan, but as a New Yorker, I mean, Larry NY is in my name. So, as a New Yorker for all my life, it's been a long time since the Knicks has been good. So it's a very exciting game where they score 8 points in the last 20 seconds or something like this, which is, to be down 5 and with 40 seconds to go and coming back to win is always exciting. And I'm just kind of pumped. And now I can actually do the problems. Day 23. Now I can't get it out of my head. What did I used to say? I don't know, but let's take a look at today's problem. 310, minimum height trees. A tree is an undirected graph in which any two vertices are connected by one path. Okay, we know what a tree is, I think. Sometimes they are messy though. Given a tree, amount all possible trees, return a list of all, okay. Those of the minimum height are called minimum height trees. Let me try to think about this. All right. So the first thing to notice is that if we are able to do n square, then this would be pretty trivial, right? You just try to you try to create every possible tree and just do a depth first search on every tree, right? But n is 2 times 10 to the 4th, so you cannot do that. So what can we do? I mean, in a way, it is. Sorry, let me think about this for a second. I'm trying to think about the case where so I think one thing that people are tempted to do, and I've been tempted to do in the past for similar problems, is this idea of just dynamic programming but memorized on the edge, right? However, there is this edge case, no pun intended, where you have a star graph, right? If you have a star graph, it will be, the short thing is that because of the way that you recurse on the node, you still do an iteration for the thing. So in essence, it is going to be n squared, right? And so that's no bueno. I'm like, give me a second. I'm like half in between sneezing, so I'm like, should I? Okay, maybe not. Maybe I'm lying. Okay. So then, in the idea here, right, or the idea I'm trying to think of, and I don't have one yet. Even though this is only a medium, only a medium. The idea here, I mean, so you always have to, for these kind of problems, you always have to do one depth first search at least to kind of feel out the tree, really, right? It's almost like a for loop in an array or something like that. You always have to look at the tree, right? So, but the idea would be to figure out a way such that you can go from one tree to another tree in better than linear time, right? Otherwise, that'll just be n squared. But I'm just thinking right now, it seems a little bit trickier as well because you have to actually do the label. So, right? So it's not. How do you reroute the? I mean, maybe I kind of gave it away a little bit, but. I mean, I'm trying to. I think I'm a little bit weaker on stuff like this because I'm trying to think. Like I have an idea, but to be honest, I'm trying to prove it. And maybe on a contest, I don't prove as much because I'm just like, well, I have no idea. Let's just YOLO it. But here, of course, I'm trying to learn as well, and for the people at home. So I'm trying to think. Have a bit of a think. Okay, so we know that a leaf cannot be the minimum root, right? Yeah. Can we do a breadth first search from the leaf? Because then, in a way, because it's almost like a sort of what you might call it, induction, right? You know that a leaf cannot be the root because by definition, if it's a leaf, then it is part of the longest. Well, not maybe the. If it is a leaf, what does that mean, right? If it is a leaf, that means that if this is the root of the tree, you only. How do I say it? But basically, if you have a leaf, the idea here is that, and this leaf is now the root. Then you always get. I have this idea of because if you have a leaf, then you only have one connection to the tree by definition, and maybe you could call it the parent, or in this case, if you reroute it as the root, then you only have one child, right? And we only have one child, then by definition, the child's depth or height in this case, the child's height, or the height of the tree rooted by the child is going to be at least one fewer, right? Because it's not burned by that leaf. I mean, there are some edge cases, obviously, with the two nodes left, that's no longer true because they both can be good. If there are three nodes, I mean, obviously, if you only have one node, then that's good. If you have two nodes, that's also a base case. If you have three nodes, then you cannot, right? Because you can have a triangle, so you have basically, well, there's only one configuration of a three-node tree, which is a linked list E thing. There's really no way about it. And from that, you could remove two nodes, so it's going to be always one node or two nodes, right? That's a hard problem, though. I mean, the implementation is easy, but I feel like this is a pretty hard problem, to be honest. What is it? UV? Oops. But that's a really hard observation to make. And I don't know how often that comes up for me. Like, I really struggle with this one. Mathematically, with respect to the proof. It kind of makes sense, but the proof is still a little bit not 100% for me, to be frank. But yeah, so then now we're trying to figure out the leaves, right? So yeah, what is it? 1 based or 0 based? Is equal to 1, then, right? Yeah, okay, fine. But I want to actually even write like a level based thing, right? Yeah, usually I write breadth first search, but I think this one is easier implemented, or ideally with level first search. Oh, it doesn't even matter, right? We don't actually have to remove this. We could just call it distance. And now that we have this, I guess this should be infinity. I think this is how I actually visualized it, but then as I wrote it down, I forgot about it. Now is going to go above left, right? And then for we in this of now. Oh. Right. Whatever. If distance of now plus 1 is less than distance of we plus 1, and of course append we, right? And then now we just get the one where it's the farthest away, right? So max is equal to max of, what's it called, distance, right? So right, for this is hard though. I don't I mean, I think I was working for it, but it's still, it doesn't feel good. Wrong answer. What the, oh no. Still visualization? Nope. Huh. Haven't done this in 3 years too. What, a lot of these arms, man. Alright, but expected 1 2. Why? Tell me why. So I don't have a visual, so I have to do my visualization by doing this. I guess I could draw it on the thing. Hang on. Let me just put on the screen so you could see it. Usually I just use the pen and paper, but to debug, I don't know how to visualize. I mean, I could use my head, but maybe it takes too long. All right, let's see. Right, so you have 0 to 1, and then 1 and 2, 1 and 3, 2 and 4, 3 and 5, 4 and 6, right? So 1 and 2 is the best answer. Why? So okay, so now we know that 0, 6, and 5 cannot after the first iteration. After the second iteration, I guess. Oh, huh. I did it. I got a little bit lazy because I was doing my logic on leaves, but in this case, 1 is not a leaf. Okay, fine. Okay. Wow. I was just being lazy. I thought that I mean, when I say I'm being lazy, it's just because it was an implementation laziness, and I thought that I made the reduction from removing leaves to the distance. But clearly this is not the case, so that's a wrong reduction. I didn't really think about it, to be honest. I didn't think it through. I was just like, oh, can I use it this way? The answer is apparently not, right? So okay, so let's actually then now reflect better what we want to say, which is degree, right? I guess it doesn't matter. But I is equal to length of adjacency list of I, and then now Okay, we don't use distance anymore. And then okay. Now that pop left, and then now for adjacency list, if degrees sub, oh, and then now we set it to 0, I suppose. Or, well, subtract by 1. If degrees sub v is greater than 0, then we do degrees of v minus 1, right? And then if degrees sub v is equal to 0, we do this thing. Yeah. Kind of what I want to switch it up is using Q2, just like so that is, it changes it to a level based thing, so it would be a little bit easier. And then Q is equal to Q2, right? And then now, and we want the last level. That's why I kind of write this in a very awkward way, right? And then basically, if Q is equals to none, then if Q, this isn't quite right. We want the last level, so we actually want answer to be resetted after this. If length of Q2, maybe, I don't know, if length of Q2 is equal to 0, then we return answer is what I want, but I don't know if this is quite what I want. Let's see, because I think I'm like I'm still one iteration late. Yeah. This is way yucky now though, but I don't know. Okay, it's returning stuff, but I think now I'm doing it one level early, right? Two levels early, I don't know. Oh, this is the while loop. I think I messed this up. Okay, hang on. I forgot how to do level based thing. Okay, so then right? Yeah, I messed this up. Okay, well, next Q equals 0. Yeah, I don't know why I'm writing it like this. Let's reset, Larry. What am I doing? Okay, so you have a Q, right? And then now we want to do a level-based thing, right? All right. Then we have while true for for now in Q, we can do this thing, right? I feel like the way I'm writing is way awkward, to be honest. So, okay. Am I still a level early? 056, yep. Then maybe I don't need. So Q, all right, so the first iteration is going to be 056, okay. And then now it does all the stuff, Q2. Q, Q2, answer. All right, let's print it real quick. Okay. Q, Q2. Why is Q2 so weird? Is this not doing it right? I guess not. Oh, if it's a leaf as one node, I am just being dumb. Okay, yeah. All right, there we go. I think I mixed up this and the topological sort where I usually write 0 degree. But yeah, let's give it a submit. Hopefully not too long. Oh no, oh, well, okay. This is just a base case. But I am being very sloppy lately. I don't know why. Expected 0. I suppose that's true. I don't know. This is such a weird case. Like I could handle it, but it is all kind of the same, right? Okay, fine. Okay. I don't know. I don't really like today's or like my solution today. But basically, it's just removing the leaves one at or at the same time. And I did a weird version of the level of breadth search. How did I do it previously? I did do it with the tree. This is wrong. That's why. Because there's the tree graph. I guess I did it the other way, that way too. Oh. I mean, this is based off using a diameter of a tree, which I kind of thought about, but that's also not a easy problem or easy solution. Man, I knew all this stuff back then. It's kind of crazy, right? Well, this one. This one I also use a diameter of the tree. Did I do it twice that way? I mean, I did it like 4 months apart, so I guess it's not surprising. But today I did it with this logic. It's not an easy logic though. I don't know. What is the solution? What? Topological sorting. Yeah, I did thought about that, the centroids, which is kind of what. Oh, I guess I didn't do it that way. But that. I mean, this is kind of what I did, but I don't know. I don't know what I feel about that. But I mean, this is basically how I did it. It's just I wrote it way more sloppily with Q1. I don't know. I hope y'all learned something today because I don't know what I'm doing today. I don't know. I need to get some sleep. That's what I'll say. But yeah, thanks for watching, everybody. I will do an extra problem after this, but stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye. Check out my other channel. Bye bye.